Okay, so I'm going to give you some quick tips and hints here for the assignment that you're working on today. Okay, this is your final assignment in this unit other than your unit exam. Okay, and this one is all on gravitation, so it will cover everything from just Newton's universal law of gravitation to satellite motion to gravitational field strength. Okay, it's very much like the circular motion assignment that you guys did so well on. Look at the point values. Don't do more work than is necessary. Okay, there may be shortcuts on some of the questions. Those shortcuts, if valid, would still be worth full marks. Okay. The other thing to really watch for, significant digits and vectors where appropriate. Okay, they may not always be appropriate for each question, but there's a couple of questions where a vector would certainly be important. So for question number 1, you've got Jupiter and the Sun, okay, and you're just looking for the force of gravity due to the Sun, or maybe we should say more accurately, the mutual attractive force of gravity between both Jupiter and the Sun. Okay, for question number 2, you are given the period of Uranus, okay, and you are told its mass, and you are looking for its orbital radius. Okay. You are in question number 3. You're given the orbital period of Venus. Okay, and you are told that its radius, the distance between the Sun and Venus, that is a center-to-center distance, is 1.08 times 10 to the 11, and you're looking for the orbital speed. In number 4, you've got an apparatus like the one we watched in that video that Cavendish built, okay, and there's a large lead ball that has a mass of 5.9 and a small ball that has a mass of 0.047 kilograms, and their centers are separated by 5.5 centimeters. Find the force of attraction between them. Okay. For question number 5, the gravitational force between 2 electrons is given, and they're a meter apart. Find their mass. Okay, we did one like that yesterday. Number 6 is talking about Mimas, which is a moon of Saturn, gives you its orbital radius and orbital period in hours, okay? And you are looking for the mass of Saturn. Number 7 has to do with Apollo 2's orbit around the moon, and it was adjusted to 111 kilometers, okay? The radius of the moon is 1,785 kilometers. So, to be clear, the 111 kilometers is measured from the surface of the moon. Okay, you may want to just make a note of that on there, because were you to orbit the moon at a center-to-center distance of 111 kilometers, you would be inside of it. Okay, so that 111 kilometers is measured from the surface. Okay, and you're given the mass of the moon there. You're looking for how many minutes it would take to orbit the moon and its velocity. Number 8, a spy satellite has an orbital radius of 2 Earth radii. What is its period of revolution? Sometimes I get people asking this question, so I'll answer it anyway. What planet is the spy satellite orbiting? And I say, what's the only planet we're going to spy on? Yeah, we're not spying on anybody but ourselves, okay? So it is orbiting the Earth, which is why it says 2 Earth radii. But yes, that question is a spy satellite orbiting the Earth. Because as far as I know, we're not spying on any other planets right now. We're researching some other planets, but we're not spying. Okay. Number 9, we've got Mars, okay, and its 2 moons, Phobos and Deimos. And it gives you their orbital radii, one of them in kilometers, one of them in meters. Okay, you are looking for the orbital speed of both. Number 10 is the mother of all gravitation questions. We did one like this the other day that only had 3 masses. This one has 4. Okay, so you are looking for the net gravitational force acting on mass 1. Okay, and that's the one that's in the top left-hand corner. Okay. One little piece of advice that I will give you, because I see people mess it up on this question all the time. This distance here is 1 meter, and this is a square. So this distance is also 1 meter, and this distance is 1 meter. that distance right there, that is not 1 meter. But I see people do that all the time. That is definitely more than 1 meter. Okay, so you might have to do a little bit of Pythagoras to get that number. Please do a little bit of Pythagoras to get that number. Okay, I want you to get the question right. Okay, number 11, asteroid has an orbital radius of 4.8 times 10 to the 11, gives you its mass, and it's asking what its period of rotation is around the sun. So there's lots of questions that involve orbital period, so there's probably a fair amount of substitution involved, okay, on this assignment. Number 12, okay, we are told the equatorial radius of Saturn and Saturn's mass, okay, and we want to calculate the acceleration due to gravity at the equator on Saturn. Now, I realize Saturn is made of gas and that you probably can't physically stand on its surface, but imagine you can stand on its surface, okay? What would the acceleration due to gravity be there, okay? And then just asking how many times greater would a person's weight on Saturn be compared to Earth? The answer to that might be surprising. Okay, number 13, the mass of one small ball and the mass of another small ball. Okay, if the center to center distance is 0.1, find the magnitude of the gravitational force between them. Okay, so nothing on there we haven't done. I mean, we haven't done one with 3 masses like question 10, but we've done one with 4. We've done one with 3. Okay, I think you can extrapolate from that experience to solve that problem. The other good news about this one is that these 2 masses here, not only are they the same mass, they are the same distance from mass 1. That might save you a little bit of time in calculating, as was my intention. Okay. All right, you have the entire class to work on that.
Not like related to the assignment, but do gas giants have a solid core?
We don't know for sure. It is theorized that they could possibly, given the immense pressure of the gases above, that there could be a solid core of maybe hydrogen or some